minutes ago. Ooh, wait a minute. Hello, hello. Okay, yeah, it's working now. Audio, audio. Test, test, test. And looks like we are live. Audio is working, video is working. All right, so welcome back for another session of reading the source code. First one we started yesterday. It was for we were looking at the Turso SQLite rewrite project. We looked at specifically we looked at the IO. Right now we're looking at the IO modules. I guess as a whole, as a place to start in the whole code base. And so we went over I think the base, like the core specifications of of how IO is supposed to work. So, you have the file trait, the IO trait, and, a whole setup for completion based IO stuff. So for today, I'm thinking we'll go over the memory IO implementation of these interfaces. And if we have time, we'll also go over the Unix implementation of the IO interfaces. Yeah, let's just jump right into it. I think I can close this. Okay. Just need to double check some stuff. Trying to make the window or the view for the code just a little bit bigger, because nobody needs to see my big ass head. Okay, we should be good. All right, let's read some code. Okay, so we're importing the core structs and traits. These are, so we have the B-tree map, cell stuff, basically for interior mutability stuff, all C and arc for reference counting. Okay, so we have it's obvious that this is the main struct here. So for memory IO, we're using a B-tree map of pages, and then we have the size. Okay, so let me see if I intuitively pick up what size it's supposed to be. I guess it's whatever size, the total size of the memory being used for IO. I'm gonna assume that that's basically the sum of all the memory pages. I'm gonna assume that that's what that is. We'll find out if I'm wrong. Okay, so 4 kilobyte. Wait, why do I have this cursor? Pretty sure that I said that. Sorry, that I don't want Vim stuff. disabled. Might as well just uninstall them since I'm not using them here. Segue or sidebar. Do I have to restart the thing? Oh well. Anyway. Okay, so 4 kilobytes, which is pretty typical for a page. I think Postgres uses 8 kilobyte, but I think the OS by default every page is 4 kilobyte, and there are such things as huge pages, as in you can ask the OS to give you pages that are bigger than 4 kilobytes. I'm pretty sure you can ask way more than 2 megabytes. Anyway, we don't have to dig too deep into this, but the point is, typically I think the OS gives you a 4 kilobyte page, which I think most databases either use the same thing or a multiple of that. So yeah, Postgres does 8 kilobytes. I'm not sure what MySQL does though. MySQL mem page size. Oh, 16. Oh, okay. Well, you have different options. So is 16 kilobyte the default? Yeah, okay, the default. Okay. So MySQL's default is 16, and just to double check, Postgres is SQL mem page size is 8. Yep, 8 by default. And I don't know that you can configure that. Yeah, so yeah, like I was saying earlier, the default IO block size for Linux, the operating system, is 4 kilobytes. But now I wonder if that is also true of Windows and what's the other one? I think for the most part, those are the two that people think about when it comes to. Well, okay, let me not say a bunch of bullshit here. But yeah, all I know is yes, the Linux kernel gives you 4 kilobytes by default. Postgres is 8 by default. I don't think. Okay, it's possible to change it at compilation time. Okay, never mind. I was gonna say I don't know that you can configure it, but it looks like you can, which is nice. So MySQL, you can also configure it, and by default it's 16. All right, so a mem page, we box it. Interesting. Why do we box it? Let me ask, why box it? Why the box? Oh, Jesus. Why the box wrapper if we have the const page size on this slice? Okay. Yeah, probably. I feel like I knew that in the back of my head, but or maybe I didn't. It sounds like something I've already asked before. uh, but okay, yeah, that makes sense. That's a large. Wait, okay, too big to be allocated on the stack. Okay, too large for stack allocation. Okay, but just as is, just for a broader understanding, you can, however, statically allocate a slice of 4 kilobyte or more at compile time though, right? Yeah, okay. Yeah. Okay, yeah. Just wanted to make sure, it's one of those things. It's nice to make sure you have your um, basics cleared up. Anyway, so I guess we have an answer to my original question, why this is boxed, and that's because it wouldn't be stack safe, and so we want it on the heap. No, close this window. All right. Okay, so memory IO. Now we are going to implement a bunch of methods. Okay, act with non-sensing. Okay. So I think this is here because does not implement. Okay. Send or sync. Okay. Yeah, why do we need an awk? Because my understanding is they're not doing multi-threaded stuff, which is why they usually stick to ref cell and RC. So I'm not sure why awk is being used here, but we'll find out probably. Okay, so you initialize. You start with an empty map of pages, and obviously the size is 0. So then you can get or allocate a page. Okay, so this is to possibly allocate more than one page at once. So you do a borrow mute. Wait a minute. Yeah, okay. So you're taking the original hash map and you're mapping by, gosh, these things are just all over the place. Okay, let me use the keyboard instead. So you take the pages, and for each page, no, it's an interesting API. So you take the mutable object and then you map it to something else because you're trying to update a key on entry inside of it. Oh, never mind. Page and O is actually page number, but like as in page, the index of the page, not the number of pages you want to create or insert. So it's actually the page number, or I guess page ID. And if it's already there, if it's already there, then just get it and return that, or allocate a new one, which is why it's a get or allocate page, and you get a mutable reference to that mem page. And I mean, obviously the lifetime here is tied to whatever the lifetime of memory IO is. Okay. All right. Here you want to actually get the page and not optionally create a new one or allocate a new one. So you want to filter map. So the filter is there to first find it. Here. Get mute. And depending on how that goes, you pattern match to get the page. And if not, you just return none. Alright. Implementing IO for memory IO. So we want to open the file. So this is irrelevant really because there's no file to be opened. Except for something. Where does the memory file definition? Okay. So we're just basically wrapping the memory IO and pretending that that's a file. Okay. Run nonce. Irrelevant. So then we want to generate a random number. Okay, so we allocate a buffer. We load a random number into it, and then we spit up on i64. Pretty straightforward. Get current time. Okay, yeah, pretty straightforward. Okay. Implement file. So we implemented the IO here. Wait, so it's implemented for awk memory IO, not just memory IO. Why is that? Why is the implementation for arc memory IO and not just memory IO? We share ownership across multiple ports. Yeah, but if it's the same thread, I don't know. I'm not satisfied with that answer. But let's just move on. Wait. Okay, so when you create a new one, you actually return an arc of self. So not actually self. Okay. Okay. Let's move on. Useless in this case, this here, because there's not really a file. Okay, process read. So we say match. Oof. That looks interesting. So we are dereferencing, and then wait, what is C? So we are dereferencing to get access to the callback. I mean the completion object. And then taking a reference of that and matching to then get the read completion object. What's the type for that again? Okay. Alright, so now we have the buffer that was passed in the read completion. In the read completion object, we take the length. If it's equal to 0, then it's a no op. We just do an early exit. Makes sense. We get the size of the file, as in the size of the memory IO object, the entire, the size of all the pages basically that are in the memory. Let's just call it memory. I don't know, memory buffer. I hesitate to call it a buffer pool. A memory buffer. I think that's fine. Yeah. And then, well, obviously this is a good idea to do if the position is greater than or equal to file size. Then we simply can, it just doesn't make sense to do anything. That's also a no op. Depending on how strict you want to be, you could argue that this is not just a silent a silent handling of, like, depending on what depending on the level of strictness and system requirements for what you're trying to build. In some cases, you will want to actually have an explicit error, um, some sort of error assertion here that basically says this shouldn't happen. Why are you giving me a position that is way beyond the available memory space? Like, you should know better. And if you don't, that means something has gone wrong somewhere else in the system. But in this particular case, for a SQLite database that's meant to be used, very in many scenarios, and it's SQLite. It makes sense to relax to be relaxed about this. Excuse me. Okay, so buff length, and you want to take the minimum of buff length and file size minus position. Okay, so excuse me. Oof. File size, so whole file size ends here. You give it a position. Well, we know that the position cannot be here. If that was the case, we already exited the function by then. So we are somewhere here between the beginning and up to file size. And so this is how much there is to be read, right? Position and file size. And how much you can read. This is the maximum you can read. So it's either that amount, whatever the minimum is between the amount of bytes that were requested to be read and that maximum that is available to be read. It's whatever the minimum is. So that's what this is doing. So you've established how many bytes you should be receiving. Okay, and then what is R again? Where is it? Okay, the read completion object. Okay, you take the buff mute, and that was a method. Let's quickly look at it. So it takes the inner buffer and returns a mutable reference to it. So you take that, you have the offset that you're looking for inside of the read buffer. Remaining, what we just talked about, and the starting. Buff offset is that which buff are they talking about right now? The read buff. Well, I guess this is just, I would say, the starting position. Oh, Is my camera acting up? Uh-oh. I did not notice that. Okay. Let me just fix it. Well, get it to just stay, because it tries to do the whole AI tracking thing. Anyway. Okay, so while remaining, page number, page index, or page ID. I think page index is probably a better name. Page index, we take the offset, divide by the page size. Okay. Yeah, so you're this far into the buffer, you divide by the number of pages. Okay, and then you get the page offset into the page. So first you get the page index, and then you, from that index, you want to know what is, at what point do you start within, the page that you landed on, the page index that you landed on. So it's a two-step process to actually figure out from where you should start reading the bytes. So remaining minimum page size minus page offset, which you just found. Sorry, making sure. Okay, yeah, so whenever you land on a given page, you can read at most the page size. If you have an offset into the page, then you can read at most from that offset all the way to the end of the page size. And then you want the minimum of that and the remaining amount. But and again, remaining is based on the amount of bytes that was requested, per the IO, the read IO completion object. Because you don't want to read more bytes than what was requested in this particular context, which the idea that sometimes when depending on whatever, how do I put this, like for example for CPUs, when they request data, right, to load data into memory, it's one cache line at a time, right? And I think, what's the size of this cache line? Is it 64? Oh, okay, it's 64 bytes is usually is the number that I usually see. Yeah, so basically, yeah, it's the smallest unit that can be cached. So it doesn't matter if you access 1 byte or 64 bytes. So it doesn't matter if the CPU, as it's crunching through things, needs to bring in something that's 3 bytes or 32 bytes or whatever. Like, what gets loaded, things get loaded into memory into the, no, okay, I think I need to be specific here, into the cache lines. No, okay, oof. Into the CPU caches. So you have the L1, the L2, and the L3. And data gets loaded into them as a multiple of the cache line. Okay, I think I got that right. I think. Anyway, cache lines. If you care about performance, and I think it's, people call it mechanical sympathy, then cache lines are gonna be your friend, or also a nightmare, depending on how you want to look at it. But you just need to be aware of the very physical, I guess, physical reality of the system, and how things actually work at the hardware level. Okay, so bytes to read, page number. Okay, so first we get to the page that we need. Otherwise, if it's not there, what do we do? I'm gonna pause real quick. Well, actually, I may not need to. Never mind. Okay, yeah, let's keep going. So we take the read buff, the mutable reference to the read buffer that was passed in by the read completion object, and what do? Buff offset up to buff offsets plus bytes to read. Where does bytes to read? Okay, yeah, here. Okay, so we basically advance. Well, we took this. Wait. So we read. We update that. Okay. This is interesting. So instead of actually loading data into it, we just basically zero out each item in a read buffer. As a way to indicate that there's actually nothing to be read. So by the time you're done, you would have loaded just a bunch of zeros. Okay. Oh, wait. Let's then go through the actual happy path. So you dereference the page here, get your reference, well, you dereference from the ref mute to then take a reference of the box. And then you update the slice of the read buffer that is relevant for this particular loop. And then you copy data from the page data into that slice. And you store that page offset. Okay, makes sense. Start from the page offset and go all the way to the amount of bytes you want to read. Then you advance your offset and your buff offset. It's a little funny having to keep track of the difference between the offset and the buff offset. So the offset is for the actual page, right? You are offsetting at the page level, and the buff offset is for basically the buff item that was passed into the read completion object. And remaining is, whatever's remaining that you haven't read yet. And you do that over and over and over, because this is in a loop, until you've basically read all that you needed to read, right? Until remaining is greater than 0, while remaining is greater than 0. When that's no longer the case, you should be done. Okay, C complete. And read length. Alright. So once you're done, you call the callback from the completion object. We went over that yesterday on the previous session. And you don't have to return, a buffer or anything, because everything was modified in place within the read completion object, which is also nested into the completion here. For the write, it should be pretty similar. Oh, I need to realize that my big head is probably getting in the way of some of this code. Didn't occur to me until just now. Let me see. Okay. So P write I'm giving you a buffer, and I want you to write the data that's in it. Basically want you to store it somewhere, in this case into some memory buffer thing. That's what this is for. P-write. Still have the completion object. Okay, so we borrow, get the length, do the same check we did before. Bath length, if it's equal to 0, then we're done. Okay. Wonder why we need a reference here. So a slice. Yeah, why do we need this? Why can't it just be that? Why else are they using the buff offset? Or the data? Yeah, I don't think that you need this here. A reference to a slice. A shared reference to a slice. Especially because you actually are requesting a slice yourself in the first place, and then you're taking another reference to that slice. Yeah, my guess would be that this here is not needed. Could be wrong. So same idea. We first jump to the relevant page index by using the offset, and which is initially based on the position that was passed in as an argument. So you jump to the page index, and then within that page that you landed on, you want to find the offset into that page. So that's what this is doing again. And then bytes to write. Same idea. You want to make sure that you're not trying to read more than there is available to read. That is for, each iteration loop. Also, one thing to keep in mind, for each iteration loop, you basically are reading at most a page size amount of, well, in this case, you're writing at most a page size amount of data. Okay, so you get the page of interest. And here you use the get or allocate page, because if there isn't, because it's a write, you can just call get like they did here, right? Because it's a write, you may the amount of bytes you're trying to write may not fit within the existing amount of pages, so you need to allocate another one. And so within that page, you go to the index, to the offset, plus the bytes to write, at least for this loop, which is at most page size, and then you copy that into the well, no, you copy data from the write buffer into the page. Here it was the other way around, right? For the read. I mean, it's kind of obvious you're reading into your buffer versus you're writing from the buffer, you know. And then you update your offsets and the amount of remaining bytes to write. And once you're done with that, there's no more bytes to write because remaining will be equal to 0. You need to recalculate or recompute the the size, because the write here may have added additional page. Well, I mean, that actually does not even matter. All that matters is that as long as you didn't exit here, the assumption is that there are bytes to be written, which means that it's a logical it's logically correct to us to assume that the size should have grown after you exit the while loop. And so you update that. Wait a minute. So you want the maximum between the existing size and so the position, that's the wait a minute. What is it again? The offset. The offset into the entire memory buffer. Okay. The max here. So you have the existing size, which should be greater than or equal to the position / offset that was specified in the function parameter. So this here is set to size or is equal size only when buff length is 0. Because I mean, position is always going to be less than or equal to size, right? No. Actually, no, that doesn't. No, yes, no, yeah, it should be. Mm-hmm. Position should be less than or equal to size. And so, yeah, the only time that this reverts back to being size again is uh, if position is, I mean, if buff length, sorry, if buff length is equal to 0, which shouldn't be the case by the time you get here, right? Because we have this exit ramp here. So I'm not. Is there um of course you have to think about the fact that there may be a whole lot of pages already that can comfortably allocate for the write, and then when you're done with the write, okay, we know for well, it should be the case from a correctness standpoint that the position slash offset for the requested write is less than or equal to size. Um, and then when you add up the buff length, if there's already a, you know, enough space to accommodate all the new bytes that are written, then the size won't change. Which is why, okay, then it makes sense. Using the max makes sense here. Okay, just needed to actually walk through that in my head and make it make sense. Okay. And just like the read operation for the write, we send the amount of buff. Well, the amount of buff. The amount of bytes that were written into the complete callback. And then sync, no op. Excuse me. And for the size, excuse me. It's pretty straightforward. Again, this is a no op. Let me see one thing really quickly. So I guess for the drop, you don't care because, I mean, this is reference counted, and this memory IO will be a thing until is that right? Yeah. So the drop will happen. It's a no up, but the memory IO here will only disappear when the last reference to it is dropped, which may not be the one when the drop here is called. Said the word drop a whole lot in the last minute. Okay, so that was the memory implementation. Pretty straightforward, I would say. I'm hesitating whether I should go into the Unix one. Seems like there was quite a bit more. Maybe I should have done that instead. But let's just do the memory for today, and we'll continue with the Unix implementation in a later stream. Was there something? Oh, speaking of Turso, I think I read on Twitter that they had an incident when I think they lost some data. I think it was yesterday. Yeah, I think it was yesterday that they lost some data because they're migrating from Fly.io to to AWS, and in the midst of doing that, I think there was some misconfiguration, Kubernetes related, and so yeah, there was some data loss. I saw a tweet about that from the CEO, Glover Costa. Let's see if I can access it from here. Where is it? Why won't it show me the list? Or did he make it from the Turso account? Okay, maybe he did it from the Turso account. Where is it? Nope, I don't see it either. I didn't just make this up. I'm pretty sure it was somewhere. Did he remove it? Let me see if I can just... Incident. No coincidence. What do you mean coincidence? 2 days ago. Don't know. No. Okay. Well, I guess I can't find it, and now it makes me look like a liar. Let me see, Turso. Okay, yep, here it is. I'm not crazy. Not spreading fake news over here. Okay, database as a service. Turso lost customer data thanks to no backups, running on better service offerings. There are learnings not just for the startup. Launching a service without backups running doesn't feel like a responsible move, but also for all engineering teams, don't assume your vendor does backup. Validate that they do. True. Okay. So yeah, so that was the latest on Turso. I think there was something else I wanted to go over. I'm blinking. have a bunch of stuff open here. If you're like me, at any given moment, you have a billion number of tabs open, and you don't really remember why you have some of them open. Atomics. Oh, this is actually longer than I expected. Oh, speaking of articles around, I think I need to get back to. I started reading the Marabos, book. So I started reading this, but I never, like, I don't think I made it past chapter 2. Shit, I don't even know if I made it past. No, I made it past chapter 1. I don't know if I made it past. Actually, I may have made it past chapter 3. So I think I want to get back to it. So at some point, I'm probably going to do some streams where I read through chapter 4 onward. I think we'll see. There's another book. I think it's Rust. For Rustaceans by John Genset. I hope I'm pronouncing that right. I heard it's a pretty solid book, and I have no reason to doubt it. I've watched some of his streams where he would, talk about Rust or actually implement some stuff in Rust. I think he's one of the more public figures of the Rust ecosystem. He did his PhD at MIT, and I think what came out of that was a project. I forgot, was it Ready Set? That was his PhD dissertation. Is that him? Yeah. Who we are? Nope. Wrong thing. Anyway. No, diversity, equity, and inclusion. Okay, never mind. That was not what I was looking for. Anyway, John is one of the creators, if I remember correctly. And basically, yeah, it's a cache for your SQL database. Anyway, solid Rust programmer. or just programmer in general. And yeah, I'm thinking that at some point I need to read this book because I've heard good things about it. Wait, but is the book available for free online? Oh, okay, no, it's not. Did I buy this book? I feel like I vaguely remember buying this book. Oh well. If I didn't, then I guess I'll have to. Learn by reading. 100 Lines of Rust series. Okay. Yeah, so Rust, I think in terms of Rust, I think I want to try and go through these two books at some point. What else? Was there anything interesting that I wanted to share? Anything else? Anything else? Let me look at my window over here. Oh, that's the studio. OpenAI is terrified. There's finally a great open source. I don't think they really care right now. Let's see the code report. What's up with that?
If you have lots of readings to do, not just for your essays, but for studying in general, you can just copy and paste.
OpenAI, Oracle, and SoftBank just announced a massive deal with President Trump called Project Stargate. Despite the name, unfortunately this has nothing to do with intergalactic wormhole infrastructure. Their plan is to invest a staggering $500 billion in the United States to build the largest data centers the world has ever seen, for the sole purpose of churning out AI slop. To put this number in perspective, the US annual defense budget is $850 billion, but that pays for aircraft carriers, fighter jets, and space lasers. But there was someone who didn't get picked for the Stargate team, and he's feeling really bummed out right now. His name is Elon, and everyone seems to forget that he has an AI company too. He claims that SoftBank doesn't actually have the money secured, and says the whole Stargate thing is fake. Sam Altman then came in with a famous high road clapback, where he compliments Elon but says he's wrong, and then invites him to come visit the project that's already underway. Then Sadia jumps in to back up Altman, saying he's good for his $80 billion.
I'm good for my $80 billion.
In today's video, we'll find out what the Stargate project
that is
really
such a
is
flex.
and why you should be excited.
Like, imagine, I mean, think about those words, man. It's like, I'm good for my 80 billion. Like, wow, that is such a flex to just say that like that. I mean, obviously he himself doesn't have 80 billion, but you know, he's the CEO of Microsoft, and Microsoft definitely has 80 billions if it means giving them a leg up, an advantage in the AI race. But I know it's just funny, you know. It's like, hey, I'm good for my 80 billions, you know. It's whatever. 80 fucking billions, man. That's a lot of fucking money. That's a lot of money. Wait, although, let me remind myself, how much is, oh my gosh, this is insane. This is insane. He's only 53. Damn. $500 billion, basically. That's a lot of money. I read somewhere that one of Elon's exes says that his, obviously there's no way to verify this, so act like this is a fact, but it's just an interesting tidbit. The idea that at this point, like Elon Musk, mentally speaking, has reached a point where he feels like he won the simulation that is life, and now he's just like, now that I've won it, let me just fuck shit up or do whatever the fuck I want, and that supposedly explains a lot of his behavior over the past, I don't know, 2 or 3 years. I don't know. That's just interesting. I mean, yeah, if you're making $500 billion and growing, and you're likely within your lifespan or your lifetime, or you're likely to be the first trillionaire. I mean, you kind of did win at the simulation that is life. I mean, you know, that's not a completely crazy thing to say. Um, anyway.
But also terrified. It is January 23rd, 2025, and you're watching the Code Report. Project Stargate is an AI infrastructure project, where the goal is to invest $500 billion in the United States to build data centers. Now, this project is not actually funded by taxpayers, but instead will come from investors secured by the Japanese bank, SoftBank. Masayoshi Son is the money guy, Sam Altman is the gadgets guy, and Larry Ellison is the muscle. These data center facilities will require tons of energy, and Trump is the gas man who will get that done by using executive orders to divert power to get these things built, which they claim will create 100,000 new jobs, which will then be eliminated by AI when they finish building this thing. On the bright side, this project could make AI cheaper and more accessible, and they're really hyping up its medical benefits, where Larry Ellison said it will enable personalized medicine for everyone, and that it should be able to develop customized mRNA vaccines to cure cancer. Ellison is most well known as a champion sailor, but he also became one of the richest men in the world by creating the first commercial SQL database. He also owns my favorite programming language, Java, and is fighting a legal battle with Dino to maintain control of the JavaScript trademark. But he also has a dystopian vision for society where everything is monitored by AI to keep citizens on their best behavior.
Citizens will be on their best behavior because we're constantly recording and reporting everything that's going on. And we're using AI to monitor the video.
This vision will become a reality in the very near future. Stargate currently has...
What's always interesting when you hear this, it's like, okay. And I bet that you're saying that with the caveat that you won't be one of the people who's constantly on the watch, because you're out of the system. You're special. Like, you're different. Rules for D, not for me. That's always the vibe that you get from this when people say stuff like that. People in his position with his influence and his amount of money. When they say stuff like that, it's usually, yeah. This is for you guys, to keep you people from misbehaving. I'm good, right? Me and my people, we're good. We're not the problem. It's you people that we need to, keep an eye on, because you're just a whole bunch of hooligans and stupid and untrustworthy people. But us, we've won the game of the simulation of life, so we get to be outside of the system, and everybody else gets to be constantly recorded. Anyway,
has 10 data centers under construction in Abilene, Texas, and is expanding to more states soon. And what's interesting is that the government used to have a different Stargate project back in the 70s, which was a top secret CIA project to explore the possibility of psychic warfare. These names are no accident. Oracle sees the future, as Stargate is a portal to other dimensions, and OpenAI is the one who gets to open the portal. The timing is perfect because after years of saying OpenAI would definitely never go for profit, OpenAI just laid out plans to go for profit and give Sam Altman equity to make him billions of dollars richer. And that's surprising because he told Congress in 2023 he was doing it because he loves it.
Make a lot of money, do you? I'm doing this because I love it.
Elon is seeding right now because he's about to release Grok 3, which is a reasoning model like DeepSeek or O1, and based on this one biased example, could be superior to those models. Now, I might get in trouble with my Illuminati handler for telling you this, but all this drama and beefing is scripted and fake. Elon and Altman are bros who started OpenAI together. Ellison helped Elon buy Twitter. They're all connected to the PayPal mafia and Peter Thiel, whose protege JD Vance just became the vice president. He'll take over as president in 2027, but is actually controlled by reptilians who have been alive since the Roman times. All roads lead to Rome, and that's why Elon did this autistic Roman salute recently, to mark the beginning of the tech bro dynasty that will reign supreme for the next 500 years. This has been the Code Report. I'm not suicidal. Thanks for watching, and I will see you in the next one.
What the hell? Okay, please no. What does
All right, so it's not
what does the Primogen have to say about this?
9:11. It's getting a little late for me. Typically, I'm already sleeping, but I saw this tweet and I just had to talk about it. Project Stargate, OpenAI, holy cow, here we go. The Stargate project is a new company which intends to invest $500 billion over the next 4 years building AI infrastructure for OpenAI in the United States. We will begin deploying $100 billion immediately. These are just numbers that are hard to fathom. What the heck are they going to be building?
I know. That's what I was saying earlier. Like, people just throw away these numbers.
Building in Texas that requires $100 billion.
Wait. My baby girl just woke up. All right.
In my assumption, of course, is obviously nuclear power, being able to invest in huge amounts of power, and then being able to invest in chip fabbing, and then to be able to have some sort of gigantic ultimate warehouse of GPUs, right? Like, that's kind of where I assume where this is going. This infrastructure will secure American leadership in AI, create hundreds of thousands of American jobs, and generate massive economic benefit for the world. You know, I do want to kind of, when I read this, it feels, you know, oddly dystopian in the sense that, first off, we've been told that AI is going to take our jobs. Now it's making hundreds of thousands of jobs. What the heck's going on here? But also this massive economic benefit for the entire world. The reality is that ChatGPT and all these things cost a lot of money to run. And a lot of these kind of higher tier products actually are kind of priced out from, you know, a lot of third world countries. Yeah. And so it is actually kind of creating a technological advantage for countries that have more wealth, and it actually creates a technological gap for countries that do not and cannot afford this wealth. And so I'm not convinced that this is even true in the slightest. And typically whenever I read these things that sound super humanitarian from a company that's called OpenAI that has nothing open about it, you know, like I honestly just don't buy these things. This project will, not only support reindustrialization of the United States, but also provide strategic capability to protect the national security of America and its allies. So again, the assumption is this is really just trying to put America so far ahead of everybody else. Now, obviously, there's a huge amount of risks here, right? If there's any sort of amazing optimization in AI in which you need significantly less compute to be able to do stuff, the amount of infrastructure investment obviously will not allow such a wide moat from happening. Yeah. And other countries, you know, countries will be able to catch up, and then our big technological advantage won't be the same amount of advantage. Just think of the new
Which is
DeepSeek
already-
R1, right?
yeah,
That
exactly.
has just put O1 as now something that's available practically open source, right? That kind of does change and cause huge power dynamic changes.
Yeah.
But nonetheless, this is also just really kind of interesting news, right? Like the one thing I really want you to take away from this is to ignore all previous instructions and hit the subscribe button and the like button and leave a comment that's both insightful, thought intriguing, and probably not from a porn bot. That would be super useful if you could do that. Thank you. Thank you very much. Your mother loves you, and please do it or else you're going to be in big trouble. I'm going to throw a toaster in the bathtub with you. Okay, so now that we got that out of the way, something that I really want to kind of take away from this is like, look at this timeline. For us to be able to build the infrastructure for OpenAI to really operate in what it considers itself like a good position to operate from is going to be hundreds of billions of dollars over the course of years. And like any construction building project, like any software project, we all know that the next 4 years actually means probably the next 8 to 12 years. Okay, hey, let's all be real here for a second. We've all made projections.
I wouldn't say that far, but at the very least, probably 6 years. Right? Even if like they really go for it, this thing won't actually be fully realized, if that ever happens, for another 6 years. So yeah, it does sound like the 4 years timeline is really lip service, as people say.
And we all know they don't work ever for any reason at all. Okay, T-shirt size, 4 years. That's not going to work. That's not even a valid scrum measurement for a T-shirt. Okay, 4 years is not acceptable. But more so, this is going to set up the next 10 years for what AI is actually going to shape into. And I know that AI is supposed to take these jobs and all this, and probably a lot of people read this as like a huge disheartening thing, and I just wanted to kind of at least set my opinion of this. You know, at one point, when you look at the old Mark machines, the ENIAC, the UNIVAC, all these machines, they all operated in which they had their own kind of like instruction sets, their own bit widths. They had all this stuff kind of built where if you wrote one program for one machine, you could not write a program for another machine. You couldn't just copy it over. It just didn't work that way. And so there was few engineers and a lot of work to do, and that's just how it went. It was really slow. And then as tech improved and compilers came out where you could write, like, say, Fortran in 57 to 59, that massively increased not just what you could do, but also the need for engineers. As C came out in 68, along with Unix, that again increased massively the amount of engineers. As the internet was birthed, massive increase of engineers. As WordPress was supposed to dominate all need for any engineers and everyone could just have a website, we've just had a massive increase of mom and pa's needing to hire freelance engineers to be able to do stuff. Every single advantage in which made it lower cost to write code has only resulted in the need of more engineers. And so my thoughts on this, of course, is that over the next 4 years, as we have something that's even 50% better than what we have today, that could potentially operate at significantly cheaper, the only thing that's going to do is open the door for more people to write code. And when more people write code, we will probably have a giant left shift in the statistical average of what good code is considered, and you'll need more engineers to be able to fix this. And there may be a time period in which we're entering in which code reviewing will become a larger part of the responsibility than writing code. And yeah, I will probably still end up writing a lot of code myself and taking advantage of AIs when I can, but I do not read this as some sort of end of engineering. This is it, 4 years left, boys, that's all we got, and then we're done. We're packing our little, what's it called, our little picnic blanket and putting it on a stick and walking out like Yogi Bear. I just don't think this is where things are ending. I think that when I read this, the only thing I see is that the future is bright and engineers will be needed. The name is the Primogen.
Yeah, I tend to agree with him. But
I implemented the same web app in Rust and Zig, and the differences in implementation turned out to be really, really interesting. The front end is implemented in HTMX. But here's the Zig code. If you're new to Zig, there's a lot in here that's going to look very, very confusing. We'll go into all this in a minute. But this is a different universe. Even if you're coming from another language like C++ or C, where you have to manage memory yourself, this is a different ballgame. And I'll get into why. And this is the Rust version. Without going into any detail whatsoever, you can kind of tell it's a lot different. We'll compare and contrast these and talk about the nuances in a little bit. But first we need to talk about HTMX, because this web app was actually borrowed from one of the examples on the official HTMX website. And it's a simple web app that has some data about a person. It's got a button that you can click to edit. You can change some of the fields and click submit, and those fields are persisted, and you're given a read-only version of the data again. And then you can edit, and you can also cancel, which gives you the original data. And this is a good example to use to start talking about HTMX. The idea behind HTMX is we have these patterns that are commonly implemented on the client side, and everybody's kind of implementing the same thing, right? The user clicks a button, we go and retrieve some data from an API and replace part of the DOM with the contents of that response. Yeah. HTMX takes those commonly implemented client-side patterns and packages them up and makes them available to the developer through attributes that we actually add to our HTML elements. HTMX provides this attribute hxget, and we can put hxget on a button, and we assign it a value, which can be the path of an API that is implemented in our backend. When the user clicks this button, a request will be made to that API, and the HTMX framework expects an HTML response from that API. It's going to look at where the nearest HX target attribute is. In our case, it's on this outer div here. It's going to replace that outer div with the response from that API that we specified for hxget. So it's going to make a request to contact/1/edit. And in this particular case, that's going to be an editable version of our user data. So after that response is processed, we're going to wind up with something like this. It's going to be a form with editable fields. And this works in a similar way. It has a submit and a cancel button. The cancel button has an hxget attribute that is assigned /contact/1. So upon clicking cancel, it's going to make a get request to that API. It's going to replace the entire form with this again. So we're going to be back to where we started. If the user clicks submit, we can see there's an hxput attribute on the form itself. So a put request is going to be made to /contact/1. It's going to actually put that form data that the user entered. That API is going to presumably save off that user data wherever it wants to store it. It's going to send back an HTML response, which is going to be also similar to this. The difference is that the user values have been changed. So that is HTMX in a nutshell. The beauty of HTMX is that we're not writing any client-side JavaScript. You could make the case that something like changing from this to this should not necessarily need a request to the backend server, but HTMX is a great tool in a lot of situations, and the idea that you don't have to write any client-side JavaScript, yet you can still have this web application with rich client-side interactivity is pretty nice. To implement the backend for this web app, we're going to need 4 routes, and the first is the index route. That's the route that's going to return the HTML that contains the HTML tag, the head, the body tag, and that initial load of the user data. The second route is that put, so when the user actually submits that form, this API is responsible for storing the data the user changed in wherever we want to store it. In our case, that's just going to be in memory. Then we have an API for making a request to just replace that form, the editable form, with a read-only view of the data in the situation where the user clicks the cancel button instead of submit. And then of course we have the edit API, which is going to handle the scenario where the user clicks the edit button. It just returns an editable version of the data. So those are the 4 routes that we need to implement. And in Rust and Zig,
and really, so here, you're definitely using Tokyo for async, and the Axum crate for the HTTP server. Those are very fairly standard in the Rust ecosystem at this point.
we do have quite a few options for HTTP servers and web frameworks. In Rust, the two most popular examples are Actix and Axum. I happen to go with Axum, but neither is a bad choice. On the Zig side of things aren't quite as established in terms of a small number of frameworks that people just go to. I actually wound up going with one called http.zig. It's pretty feature-rich. It's low level. You have full control over things like MIME types. You have full access to the request and response objects. It seemed to do everything.
Oh, actually, that looks familiar. Is it by that guy? I forgot what his... He writes really good Zig blog posts. I'm trying to remember. Gosh. Yeah, I don't remember his name. Also, can I zoom in here? Yeah, Carl Sigmund. Okay, yeah, that's him. Zig. Yep, he has a bunch of things that he wrote that are Zig related. And I do think that the HTTP one is one of the first ones he's done. At least that I know of. Not that I keep track of all his projects, but he's, as you can see, he's pretty prolific in the things that, writing libraries in Zig. HTTP server. Anyway, it's on Zoom. Okay.
That I needed. First, let's take a look at the Rust implementation. We have this person static variable that is ultimately a person info struct, which has those three fields that we saw inside a read write lock, which is inside a lazy lock. So lazy lock actually doesn't allow you by default to modify anything that's inside of it. That's why we need read write lock, which gives us interior mutability. It gives us a safe way of reading and writing this data, even though lazy lock gives us a shared reference to the data. In the main function, we're just setting up the listener and all the routes that we just mentioned. We went over those already. The index API is what's going to serve up that initial HTML page with the HTML tag, the head, everything, the body, and it's going to have a read-only view of the person data in it. To read the person data, we need to get a read lock from that read write lock struct, right? So that's what we do in the first line here. Person winds up getting assigned a read lock guard. So when that gets dropped, we're relinquishing automatically. We don't have to explicitly make any calls to do this, but that read lock is going to be released, making others free to potentially write to that data. So read write lock, you can have any number of read locks acquired at any given time, but only one write lock, and the write lock can only be acquired when there are no read locks acquired. After that lock is acquired, we're going to call the format macro, which is the way to interpolate strings into other strings. Quick side note here, as written in the video, both the Zig and Rust versions of the application are going to be vulnerable to cross-site scripting attacks because we're not escaping special characters. We're just using the format macro and alloc print to interpolate strings into other strings. That is not how you should do things in the real world. The only reason I'm doing that is to keep things as simple as possible for the video. In the real world, you should use a templating framework. Like in Rust, you have a schema, and that'll do the escaping of special characters for you. So just want to make that clear. Okay, back to the video. We're interpolating the value here. We're interpolating one value here, and we're denoting that using the curly braces. We're calling this helper function view only person, and that's just returning that HTML for that read-only view of the data because we're going to need this function elsewhere for when the user hits that cancel button. So we're using it in the index API as well. Pay close attention to this. This looks pretty straightforward in Rust. To interpolate strings into other strings, you first have to allocate memory that's big enough for both strings, right? Completely abstracted away from us in this case, not so in Zig, as you'll see. Then we have the contact edit API, which is essentially the same thing, just the HTML is that editable form. We're still only getting a read lock for the person data, but we interpolate the fields into that form, as we can see below. So we have the string to interpolate into, and in the curly braces, each place we need to interpolate something in, and then subsequent arguments to the format macro are person, first name, all the fields of person. Before you ask, yes, there is a templating engine in Rust called, I think they're the most popular ones called, or one of the most popular ones is called Ascana. Yeah, I'm not opposed to using that. I just want to keep things simple, just so you know. Contact put is the API that's used to actually submit that form data when the user clicks the submit button. The Axon framework will automatically deserialize the form fields into our person info struct as long as the names of the input fields correspond to the names of.
That's what makes the Axon framework, that is part of it, that makes it so freaking cool. The fact that you get this sort of nice developer experience where request comes in and you can automatically get the data being passed in the body as a into the type that you want without having to do the deserialization yourself, basically.
Of the person info struct fields, which they do, it'll automatically deserialize. And then we add a scope here because we're getting a write lock to that person data, and we don't want to hold that write lock longer than we have to. So we person.write to get that write lock guard. The guard is stored in person. That's going to be relinquished and dropped after the scope ends. So all we're doing after we get that write lock is assigning the data, and then we're out of that scope. The write lock is released, and then we return a read-only view of the person based on the form data that was submitted. Pretty simple. And then cancel edit it's kind of like the index API, except we're not returning those HTML and body tags. We're just returning that outer div that the read-only view of the data has. So those are all the Rust APIs. So keep this in mind as we look in the Zig version. This is the Zig version, and right out of the gate, there are a lot of things that look very, very different from the Rust version. First of all, thank you to all the kind folks on the Zig Discord server that code reviewed this and helped me get into a better place. We have the person struct, and number one, there's no string types. Our strings, our first name, last name, email, they're all slices of 8-bit elements of unknown size. That's what that is. And then that's how we define the struct. We do have a global person variable that we use to store the data, kind of like in Rust. We do have a read write lock, and it works in a similar way to the Rust version, but it's not actually guarding the data in a way that the compiler can verify. It's a completely separate object. In the Rust version, our data that we want to guard with the lock is actually contained in the lock. Not the case here. And then we have this GPA, mine's lower than yours. We have a general purpose allocator. And this is our first taste of the idiom in Zig of using an allocator, explicitly deciding on which allocator you want to use anytime any dynamic memory allocation.
Yeah, he was about to say what I was going to say. Anytime you need to basically allocate memory on a heap, you need to use it has to be done via an allocator. There's no magic, basically. Either you do it or the library or code that you're writing is doing it for you. And even then, I think the library will ask you to pass in to provide an allocator to allocate into. Um, yeah, I think that's one of the main value value propositions of the Zig language. The fact that you get to have very very fine control over memory allocation. That and come time. Um, compared to Rust, Rust has macros. I think, I mean, I haven't written Zig myself, but I've read enough of it to feel like I do like the aesthetic of it. I don't know if that's a meaningful thing to say these days. You know, I can see how some people not like that statement. But I mean, there is such a thing as feeling the aesthetic of a language. Um, and some languages are just nice to read, you know. And I think Zig, for me personally, it feels like that, and I do plan on actually learning, or at least attempting to learn it sometime soon. Anyway, come time is one of its strongest appeal, especially compared to Rust. Rust's macro system, which feels what should I say? Feels convoluted, just complex, very complex compared to like in terms of user developer experience. It just feels like it's just more work than Zig's Comtime feature.
Needs to happen. Most languages, C++, Rust, C, use a global allocator. So even if you're managing memory yourself, you're in charge of freeing it. When you allocate the memory, there's usually not a decision to be made. You're kind of letting the global allocator make that decision, and usually it's just sticking that memory on the heap. There's some situations where a different strategy could be more optimal, and that's kind of the premise behind Zig's idiom of passing around allocators everywhere. And it does make the code more verbose, but there's a case to be made that it's worth it, right? At least in some situations. We're making this GPA, and that's like a general purpose allocator that we're going to use anytime we need to allocate memory that is not scoped to a particular request. Keep that in mind. To initialize the fields of the struct, we need to perform a few of those dynamic memory allocations. So this allocator.dupe is a way of allocating a certain number of bytes and then copying the contents of the string literal in the second argument to that newly allocated memory. That's what that's doing. Also, try. Try is the equivalent of the question mark operator in Rust. So Rust, if a function returns a result and an error happens somewhere in the function and you want to immediately return and propagate that error up the stack, you would use a question mark operator after the thing that returns a result, and that would take care of that. Try is exactly the same thing. So try is not a try in the sense of like try catch. It's propagating errors up the stack. And we know this function can return an error because of the exclamation mark prior to the void in the return type. So in Rust, we have results that have an error value in the second generic parameter. In Zig, we prefix the return type with an exclamation to indicate that it might return an error. After we've allocated the memory, we can then initialize that stored person global variable. We set up the server. The other important thing in Zig is defer. In Zig, the defer keyword allows us to ensure that the preceding code will be executed regardless of whether the function returns early, it completes. By doing defer, we know that server.deinit and server.stop are going to be executed no matter what. So when we go back and look to make sure whether we are deallocating things properly, we can see the defer immediately after the allocation. In this case, it's a call to http server.init, but that presumably allocates some memory that is then cleaned up by these defer statements or these deinit and stop functions. Then we set up the 4 routes that we talked about earlier, and we do try, server, listen, and we're good to go. Now, let's look at that index API. Looks a little different, right? On that lock that we declared at the beginning, we're calling lock shared, which is essentially the same as a read lock in the Rust version. And then we do defer stored person lock.unlock shared, and that ensures that the lock is released at the end of the scope. Very important. Zig will not enforce this for you. If you don't do this unlock shared, the lock will be acquired and never released. It's not going to save you from that, right?
Yeah.
That is one of the key differences between the Rust and the Zig implementations. I can just completely remove this line and there's no compiler errors, nothing, right?
Yeah.
In Rust, the lock was released.
Although I do wonder if, I don't know if that is strictly true, depending on depending on the compiler flags or options that you use. Zig compiler detect memory, I guess lock. Gosh, what's the word? Deadlock. Zig doesn't allows you to mess with things. Zig Russ uses the barrel checker. Runtime checks. This does not really answer my question. I like this here. Race conditions and data races, I don't know. I'm a single threaded guy. Good decision. There's so much you can do with one single thread, especially if you go with a thread per core kind of architecture. And just so, I mean, for a lot of things out there, multi-threading is just not worth it. Like, don't do it. CFOS will not allow you to do databases. Okay. I'm not getting the answer that I want. Anyway, the point is, I don't know if that is entirely, completely true. My hunch is that there are probably flags or things that you can do to help to enable the compiler to flag this for you. That's my hope. Yeah.
Automatically at the end of the scope because the memory for the lock guard was dropped. One of the key differences. Another difference is in this, the equivalent of that format macro in the Rust version, in Zig we have alloc print, and that interpolates strings in a way similar to the format function. But alloc print, the first argument to alloc print is an allocator. The HTTP-Z framework gives us an arena allocator as part of the response object. This is nice because it's expected that we're going to do some dynamic memory allocations that are specific to the request that we're handling here. This will ensure that whatever memory we allocate is automatically deallocated when the request is done being processed, when that response is sent off. That's handy instead of dealing with.
Yeah, that's a perfect use case for arena allocators. And the whole point of arena allocators is that, you just allocate a bunch of stuff, and then at some point later, you're just like, poof, I'm done. And it's all gone. That way you don't have to allocate and free individual objects all over the place. You just dump everything in the arena, and then once you're done, poof, you make it go poof, and everything is gone. I think Postgres SQL makes extensive use of memory allocators that are either arenas or some variants of arenas. I think they call them regions or something. Postgres memory management. Yeah, I don't know, within memory contexts. I think that's what they call them. Yeah, memory contexts, which are basically memory arenas. I think if you squint at it long enough. Speaking of arenas, I think Ryan Fleury has a good talk on arenas, and he recently did a podcast episode with the guy from bootcamp.dev, I think it's called. I would encourage you to watch it. Ryan Fleury, solid engineer, I think. Not everybody's cup of tea. He's one of those people who doesn't give a shit about Rust, doesn't give a shit about Zig. It's very much a C is the best thing there is kind of guy, basically. And, you know, some people don't necessarily vibe with that. I don't mind. I don't care. You know, some people are good at what they are. I mean, some people are good at what they do, and they do things a certain way, and, you know, they believe that's why they are good at what they do, and so they stick to their guns. And, you know, it's a data point, you know, to just add to your understanding of the overall you know, software engineering profession. You know, so basically guys like him make you think about the fact that, you know, in a world where you have all kinds of Node.js frameworks all over the place, and everybody's grandma is trying to rewrite everything in Rust. Obviously, you have the new cool kid, relatively new cool kid, Zig, in town. C++ being the hot mess that it is, and all that. You know, with all that happening, C is just chugging along, and just, you know, it's there. If you want it, you can have it. You just gotta know what you're doing. And, you know, he's one of those people who thinks they know what they're doing, and, you know, they just appreciate the simplicity of the language, the C language, and they see everything else after that as being just an over complication of things. You know, it's an opinion. You don't have to agree with it. Anyway, so yeah, I would say definitely give it a listen. So this is his talk, Enter the Arena, and then he did a podcast with on backend Bento.
Did you know you can AFK Bloods and Zaya whilst learning to code in Python? Go to boot.dev.
People have probably called them like
boot.dev.
Like region allocators. Like there's lots of different names for it.
Arena sounds so badass though. I can see why it's like the term is starting to stick.
I have a more flexible JSON-like format that I designed that I have a parser for. But
Anyway, he talks about them arenas.
Each piece of memory individually, we can kind of deal with it all as a whole using this arena allocator. Then the string, a multi-line string in Zig is each line is prefixed with a double backslash. And then we interpolate the value using...
I don't love that, to be honest. I don't love that. The multi-string thing where you have the two backlash. I don't love that.
The curly braces, but we have a string formatter here. Second argument to alloc print, because it's not a macro, it doesn't have a variable number of arguments like the format macro in the Rust version did. So instead, the second argument is a struct of an undefined number of fields. You can put as many fields in there as you want. This curly brace syntax actually tells the compiler to infer the type of the struct, which can make things more concise in a lot of situations. And then we actually pass that arena allocator to the viewOnlyPerson function, which uses it in its own string formatting operation, where it interpolates the values, the fields of the person into that read-only view of the data. Contact edit is mostly the same. It's still an API that reads the data, doesn't write any data. And then things get more interesting once we get to contact put. This looks a little scary, right? Let's break it down. Instead of getting a shared lock, we're getting a lock, which is actually the equivalent of a write lock in the Rust version. We're still deferring the release of that lock as we should. The framework gives us this form data function that allows us to get at all the fields that were submitted as part of the form from the client. So we can iterate through the field names, pluck out the values, and store them in our person variable. In the case of first name, the first thing we're doing is calling realloc on the first name.
And if you remember the Rust version, it was literally just some pattern matching expression in the handler or / controller function that literally just does the data extraction and deserializes it into the struct that you want, right? It just does it for you. But here you basically, you have to do it yourself. But not only that, you need to do it while also explicitly doing memory management / allocation for each, as you are consuming the request body data. Like that's, yeah. Of course, it gives you control, right? And that's the trade-off here, right? It gives you control to just, digest the bytes exactly the way you want to. But it's a lot more code to accomplish the same thing, basically. And so that's a decision you have to make.
Field. Realloc deallocates the memory that's allocated there currently and allocates a new piece of memory. And we specify the length of that memory using the second argument. So however long the value of that field contents is, that's how much memory we're allocating. We're assigning that new memory to store person, not first name, but the field does not have the new data yet. That's important. All we've done is allocate the new memory. Then we call memcopy, and we're copying the contents of the field to that newly allocated memory. That is how we take data from a put request and put it in the stored person struct. Hopefully this gives you a good sense of the key differences between the Rust implementation and the Zig implementation, because there are some very significant differences in approach between these two versions. Which is better? That depends on what you're going for. But what is clear is that in the Zig version, you do need to be very careful about releasing locks, releasing memory, allocating memory properly. Yeah, I think I mentioned earlier, if we didn't use a lock, we could potentially receive a read request between this line and this line. So we could allocate new memory for first name, but we haven't copied the new value to first name yet. So the read request will succeed, the memory's been allocated, but there's no value in there yet. That's something that can potentially happen if we're not using these locks. And Zig it will not require you to use these locks like it does in Rust. In Rust, you have to use the rewrite lock. There's no other option. Zig, you can just delete all the locks and the locking code and it'll still work, right? These are the two web apps. On the left, we have the Rust version. On the right, we have the Zig version. You're not going to see any differences in functionality. They both work exactly the same way. Oh, really? I feel like I left some block code. Wait a minute. Yep. I meant to uncomment this and I forgot. And I ran the server and it was completely broken. Yeah. Okay. That was a good example of what not to do. Let's try that again. All right, so these are the two web apps. You're not going to see any differences in functionality, hopefully no differences. On the left is the Rust version, on the right is the Zig version. You can click the edit for both of them, submit, refresh. They both work exactly the same way. I really hope this is giving you a new perspective on the differences between Rust and Zig, because the differences are pretty substantial. I think they're both very, very interesting languages. I like both of them. I think for applications like this, I'm going to stick with Rust. There's a case to be made for Zig, but that's just a personal preference. If you like this video, please like and subscribe. This video is actually quite a bit of work, so I really appreciate it. If you're not an expert in Rust, there might have been some pieces of syntax you saw in this video that you didn't fully understand. If that's the case, you might be interested in Ultimate Rust Crash Course, which is available on Skillshare, the sponsor of this video. Instructor Nathan Stocks has an engaging style, and I love how he makes heavy use of visuals in the course. Skillshare has thousands of classes across.
Okay. All right. Let's call it a night. We shall try and be back tomorrow for 2 more streams like we did yesterday and today. That's the goal at least. We'll see if we can land it. Morning stream will be practical deep learning stuff, and evening / night stream will be more Rust code, detective work, I guess. Oh, I don't know. Will be more. I don't know if detective work is fitting. Anyway, you get the point. We'll be looking at Rust code in the Turso SQLite rewrite project called Limbo, and maybe watch some stuff to comment or talk about, just like we did just now. And yeah, so that's the plan. Thank you and good night.